Hi, Paul with Diode Dynamics, and today we're talking about HIDs versus LEDs when it comes to upgrading your headlights. Now, there's a lot of regulations state by state. Today we're talking about how these two different technologies actually work and what you can expect to get in your vehicle. Now, that's the first big note to mention. When it comes to bulbs and headlights, it all comes together to make one optical system. So the results and the beam pattern is going to vary based on your specific headlight design. But there's a couple things we can talk about that are going to give you an idea as to what to expect when you're considering LEDs or HIDs. We start with the actual bulb itself. The most basic is our halogen. That's going to be a wire filament, so just a coil of wire that's going to be emitting the power. You can see on the bottom of the bulb the voltage rating and everything. The voltage is going to be going straight through that filament, which acts as a resistor, and it's going to emit light. So very basic, very tried and true. When it comes to HID, instead of a filament, we have a capsule, and right in the middle is where there's going to be an arc generated. So the light is coming from an electrical arc, and that's what makes things a little tricky. We're always going to have a return wire to connect it from one side down back to the base, and these are going to run at about 45 volts, usually AC power. So much different than the 12 volt DC in a vehicle. We have to do some special things to get power to these effectively. When it comes to our LED bulbs, we're always going to have emitting points somewhere with different types of LEDs, but these are going to vary hugely in the way they're designed and constructed. Some of them are going to have internal regulators for the power to come in, but the LED chips themselves are definitely not going to run on 12 volts. So we need to regulate that power in some way. So, as we mentioned, the halogen bulb is just going to use 12 volts from the vehicle. Very straightforward. HIDs, on the other hand, are going to operate with an arc in that bulb. Now, that arc is not an easy thing to generate and maintain, so we need something called a ballast, which is going to keep that running smoothly through the bulb. The ballasts you'll find on the market now are these slim style ballasts. One thing you'll note with them is that on the output side, you'll always have a box of some sort, and what that is the igniter. So we have to get the right power going to the bulb, but to get that arc started, we basically have to spark across. So these are going to generate up to 25,000 volts, 22, 23 kilovolts usually. And that's going to get that arc started so the light can start to come out. That's the main reason why these older ballasts are so thick. If you put this together, you'll see it's basically the same size. All they've done is move these igniters external, and that way the ballast itself can be smaller. But what's in the actual ballast? Well, it's not easy to keep that arc of light running. So these ballasts are basically little processors, little computers. And what they're going to do is they're going to analyze this arc as it's running. Now, when you ignite that bulb to get it started, it'll spark for a second, and then it'll gradually warm up. And what that is it's actually monitoring the resistance of this arc, and the ballast is delivering more and more power so that this arc can get bigger and bigger. This is the same way it works in stadiums and that sort of thing. So in stadium lights, they're way bigger arcs, so it can take 30 minutes after a stadium light comes on and it slowly gets brighter and brighter. In HIDs for vehicles here, much lower power, much smaller arcs, it can still take 10 to 30 seconds to get fully warmed up. But that's basically how the HID system comes together. As you can see, there's way more going on to them than our standard halogen bulb. And the fact that we need to use this microprocessor in here to really regulate that arc, the igniter to get this arc started, it's all just a lot of parts coming together. And the problem is a lot of these aftermarket ones are built to a cost. So you can buy these kits for $2, $3 for the whole set. You're not going to get good components. So with good components, they can work well, but there's always a lot more that has to go into them. So how does that compare to LEDs? Well, with LEDs, we simply have the LEDs on the stalk here and then going to the base of the bulb, and most of them are going to have these little boxes coming off. But these aren't what we refer to as a ballast. A ballast really monitors the arc of a power, and so we use that term for HIDs, fluorescent lights, that sort of thing. These are what we would call drivers or regulators. Most commonly, they're just going to take your 12 or 13 volts on the vehicle and convert it down to 9 volts or whatever voltage is required for the LED bulb design. LED bulbs do require constant current going to them instead of constant voltage, so we have to use a constant current supply. So we'll actually make sure that about 1 amp, 1.2 amps is traveling through those LEDs very uniformly to keep them very reliable. Still, it's much simpler than the complexity of maintaining an arc of power, so these are generally much simpler, much more reliable over time, and much less expensive versus a whole ballast. Now, what's the difference in how these actually turn on and operate? Well, with HIDs, as we talked about, it uses an arc that needs a spark on and then gradually turn on. Now, even if you find a special ballast that's advertised as fast starting or fast bright, it's gonna take a couple seconds after that initial spark, which is one reason they're not too great for high beam use where you wanna use them as indicators. It's gonna take a couple seconds for them to get to full brightness. Once they do get to full brightness, they're going to maintain that brightness level no matter how long they're on. With LEDs, they will instantly turn on, which is a big advantage. But one thing that most people don't talk about with LEDs is that it's going to be 100% brightness only at the instant they turn on when they're nice and cool. As they heat up, they're going to reduce in brightness down to maybe 80–85% of that original level. And with really cheap bulbs that aren't well designed, it might only be 50 or 60%. So it's important to choose an LED bulb that's going to maintain the output at a very high level with good thermal performance. We have another video on this where you can see on camera the actual LED brightness decreasing. It's pretty crazy. But once it reaches that steady operating temperature, it will maintain that output very nicely. So once these are running, how are they going to work over time or eventually fail? Well, with a halogen bulb, you might think, okay, it's just gonna go out after a while. That's not quite the case. Halogen bulbs are going to decrease in output over their lifespan until they finally go out. This is actually why if you go in the store and look at halogen bulbs on the shelf, they'll say 30% more output. They're not saying that the bulbs themselves are brighter, they're saying that they're brighter than your worn out bulbs in your vehicle. They've actually been sued for this type of marketing. It's a little misleading. All bulbs that are brand new halogen bulbs are going to be about the same output level, and you can improve your output if you replace your worn bulbs. That applies to HIDs to some degree as well. So with HIDs, assuming you've got a good ballast, it should keep running forever. But the bulbs, the actual electrodes, are going to actually wear down over time, and they're gonna spread out so that it takes more power and there's more resistance in generating that arc. What that'll do is decrease the output drastically, and it might color shift or fade it to a bluish type color. So there's a lot of vehicles now with HIDs from the 2000s, and a lot of people come to me asking, well, my HIDs aren't as bright as they used to be. The best thing to do is just try new bulbs, because if somehow those bulbs are still running, eventually the arc won't be able to be maintained and it might flicker or keep igniting. But if that thing's still running, it might be really dim and a bluish color, and you can fix that with a new set of bulbs. With LEDs, these do also degrade over time. Now, a good LED that's running at the correct operating temperature should last for decades. But with high power LEDs, if they're running too hot or if there's too much power going through them, they will quickly degrade, so that the output today might be way more than the output 3 years from now after a lot of use. This is a huge factor for cities buying streetlights. They can't have the light actually less output only 2 years later. They have to make sure 10, 15 years, 20 years down the road, they're going to be getting the same amount of output. This is something called lumen maintenance, and it's a big factor in LED design. Unfortunately, the majority of the LED bulbs on the market are running way too hot, and they will degrade after only a couple months of use. There's only a couple good ones out there. They're going to maintain a nice, cool operation for the chips so that they'll maintain the output for years and years of use. So we talked about how light is emitted. Now, what determines the color of that light? Well, with HIDs, it's going to be determined by the halide salt mixture in the capsule itself. That's that yellow stuff if you look at an HID bulb. This will evaporate and actually allow that arc to be generated inside of it, and that's going to determine the wavelengths of color that are generated by this arc type bulb running. Just like fluorescent bulbs, HID bulbs are going to generate spikes of color, and we'll put something up to show that. The colors generated are going to be a lot of UV light as well, and that's why we have this second tube around it. So you might have heard how the bluer an HID bulb is, the less real output you get. And there's definitely truth to that, because as you shift more towards blue, you also put more of the energy into that ultraviolet wavelength that's just going to get blocked and of course is not visible. So to get the most output, you want to use a nice pure white color with HIDs. I'd recommend no higher than 6000 K. Now with LEDs, we only have one choice. Unlike HIDs where we had all the colors under the sun, we only really have one choice of color with most LED bulbs. Normally it's going to be around 6000 K, and that's just because that's where the LED chips are produced. If you look at a factory vehicle on the road, OEM LEDs are just always made at that 6000 K level. Now with cheaper LEDs, you might notice that they use bluer chips or something. And that's because with the way LEDs are manufactured, it's actually more expensive and less efficient the more and more white we get them. So that's why all the first LEDs in the early or later 2000s were a really bluish white, and nowadays we can finally get warm white LEDs everywhere. It just takes more materials, and it's harder to get a lot of output with a warm white color versus cool white. So still, with cheaper LED bulbs that don't use automotive chips, you might get really bluish color output. Even with CREE LEDs, these are going to be well controlled. They're not automotive, so there might be more variation. And of course, this COB type, these are basically custom made, and those are usually going to be really poor in color performance. If you get good bulbs with automotive style LED chips on them, you should have great color uniformity over the life of the bulb. So with the light that we're generating, what's going to determine the total output or the intensity of that light and where it's shining from? Well, if you look at our halogen once again, we know it's based around that filament coil, and it's a very specific amount of lumens or total output that has to come out of a halogen bulb. When we compare that to HID, the HID is going to generate nominally about 3200 lumens for a good 35 watt bulb. And that's one important thing. For our cheaper ballasts, they're just not going to output 35 watts to the bulb, so you might only have 2000, 2500 lumens. With a good HID, we're going to have 3200 lumens coming from this arc. And we can see the arc has been designed to sit exactly where that filament is. The problem with this is that the arc is still a little bit taller and a little bit wider than that filament. So it's not exactly in focus, but it is centered where it's supposed to be. The main issue when it comes to output performance with HIDs and glare is that there's way more output. So 3200 lumens compared to usually about 1500 lumens here. Double the output from the same point, a little bit bigger, means much more light that your headlamp might not be able to gather, collect, and focus properly. Now, when it comes to LEDs, the big issue is that there's just a huge amount of variance. So if we look at a cheaper style of LED here, we can see it uses the COB type chip. So this is a much bigger emitting area here compared to our filament, and it might only be about 1200 lumens. So the output isn't higher and it's out of focus, which is basically horrible in both cases. So with this, something like this, we're just going to end up with something that's a blob of light on the wall and dimmer than your original halogen. So with LEDs, we need to fix that by at least using chips that are designed to be the exact same size and intensity as that filament in the halogen bulb. So here we have nice ZES LEDs. They're designed to be the same size as this filament, and we're going to make sure that this bulb is running with high enough power to match or exceed the output of the halogen bulb. So here with the Diode Dynamics SL1, we get a true measured 1700 lumens of output. And the halogen with about 1500 lumens means we're going to get increased output with the same nice focus. Now, the last thing I'll mention with LED output is that you'll see ratings of 10,000 lumen LEDs, 5,000 lumen LEDs. Is it one bulb? Is it two bulbs? They don't really say. And that's one thing to be very wary of when it comes to output performance ratings. These bulb manufacturers very rarely actually measure the output of the bulb. They'll just look at the chips on them and basically give it a guesstimate on what that you can expect. It's very, very rare to see any LED bulb actually outputting more than about 1600, 1700 lumens. There are some that are brighter, but normally they're going to use bigger chips on them than 2 in order to get the heat out of those chips. So you might find things that are brighter, but they're not going to be focused, meaning that brightness doesn't matter. But just be very wary when you see ratings from people and ask, did they actually measure it? We're fortunate to have facilities here where we can actually put these in something called an integrating sphere and measure that output so we know what the true output of the LEDs, the HIDs, and the halogen really is. If someone's not measuring it, then it's just guesses or recommendations from the manufacturer, and in most cases, it's just marketing info and not correct. Now we've looked at all this information on the differences of the technology itself, but how is it going to actually apply to your vehicle? Now, as we mentioned, the focal point and the geometry and the design of your headlamp is going to play a major factor, but another big factor is the electrical system on your vehicle. So especially on newer vehicles, all the electronics are powered through the BCM or body control module of the vehicle, not through just a relay and a fuse. And that means they might have a flickering signal. They might be monitoring the power going to the bulb. In most cases, that's really helpful. For a halogen bulb, we can actually sense when the coil is breaking down, and the vehicle can know when the bulb is going to be out soon just because there's more and more resistance as that filament breaks down. So it's great, but when we look at putting HID or LED into that, it might not work perfectly. Now, HID uses a lot of power when it starts up. It's because of that ignition that we mentioned. It might draw in 7, 8, 10 amps of power right when it starts up, and that alone can cause some issues, especially on older vehicles. For that reason, you'll see relays used a lot to basically add new wiring to deliver enough power straight from the battery for the HID system. There's not really that problem with LEDs because we're only going to be drawing maybe 20, 30 watts at most, and we don't have that spike of power going into them. That's the big key. So we don't really need to worry about bulking up or beefing up our wiring on the vehicle, but with both of these systems, the other half is that monitoring or the flickering signal. So with HIDs, some of them now have built-in big warning cancelers or error cancelers you might see. They'll be called CAN bus very commonly. And all this is basically going to smooth out that power signal before it goes to the HID. Even with this, sometimes that initial surge of power might be too much and it might trip up the vehicle's system. It's most common on a lot of Dodge vehicles these days where it can be really tricky. So you can buy extra little adapters, CAN bus adapters they're called, to fix that. Again, it just gets more complicated with HIDs, but if you find something that's designed for your vehicle, that's what you know should work. With LEDs, you might still need that from time to time, most commonly with flickering signals. So if the vehicle is sending a flickering signal to the bulb, you still need to add an extra adapter of some sort to smooth that out. Again, check it out for your vehicle, but in most cases, it's not going to be quite as complicated as what you need to do for HID setups. Now finally, let's see how these really compare in a couple headlights. Now as I mentioned, it really depends on your specific vehicle and headlight design to determine the best choice for you. But there are two major differences in halogen headlamps. The first design you'll see is reflector, and that is when we have a light source that then shines into a bunch of mirrors, just bouncing once into the road. That's very common. It's the cheapest type of headlight to produce, but these days, with advanced computer design, we can get really nice output patterns. The other type of headlamp is known as a projector headlamp, and that uses a lens. We actually have just a projector right here. So you'll see the lens on the front of it, but inside we put our bulb and then there's a bowl around it. This is going to be a parabolic reflector, and it's going to function to essentially collect as much light as possible and shine it forward into the lens to be distributed. So as you'll see, we can more effectively collect more of the light with a design like this. And let's check out now how these compare with LED and HID installed in each. All right, we've got our Dodge Ram headlight here. This is a reflector style headlight, as you can see, with the nice mirrored surfaces in here. Now for these tests, we're going to be using a lux meter and just showing you the peak intensity, but we're going to look at the whole beam pattern as well. We're going to keep our camera setting solid, just set to the same level so you can get a nice comparison. So we've got our halogen to start here. When we turn this on, we can see we've got a nice hot spot in the middle and width on both sides. The max lux that we've measured from this distance is 1190. Now I switched over to the HID, and when I light this up, you can see how long this is going to take to start up. So of course, some ballasts are going to take longer than others, but we can see the effect of that here. Now as it warms up, it's going to shift from a bluish up to a whitish color as well. So we'll let this get up to full operating brightness, and then we'll measure the lux here too. So now it's fully bright, and we measured it, and we got 1580 lux. So that's a big improvement from our halogen reading, but the problem is we have more light everywhere now, and that includes extra glare above our cutoff pattern. So with reflectors, there's just no real good way of controlling that extra glare because we don't have any type of shield like we'll see in the projector. So reflectors with HIDs, we have to be very careful because not only are we shining more light in the hot spot, we are also shining more light above it and creating glare for other drivers. Now let's take a look at the LED. Next we have our CREE LED installed, and these aren't even the worst type of bulbs like the COB, but they're so out of focus still with that bigger CREE LED on it. In this case, you can see we don't have any hotspot anymore. It's really just blurry and just out of focus. So on this, we only have 840 lux, which is a big downgrade from halogen. So when it comes to LED bulbs, the first step is you want to make sure you're getting a good LED bulb that's focused. Next, we're going to be doing the Diode SL1, and we'll see how this performs. So when we light this up, you can see immediately a huge difference in the quality of these two different LED bulbs. This is the Diode SL1, which is using nice high-intensity chips arranged perfectly with really good focus. And the result is clear. We have a nice, strong hotspot, and that hotspot is actually 1660 lux, which is higher than the HID in this headlight. And that was a good HID. Of course, it's a 35 watt HID. If we go to a higher power HID like 55 watt, we might get more output from the HID. But again, with that HID, we'll get more glare. In this case, because the LED is so well focused, we get a huge increase in output without added glare like the HID. So in most newer reflector housings, the LED, a well-designed LED, is going to be your best bet. So now we've got our projector headlight here, and when we flip this on, you can see big difference from reflector to projector headlights in the way the beam pattern looks, mainly because we've got a cutoff shield that's going to block any light from going over that cutoff line. With our halogen bulb installed here, you can see we've got a nice, very even pattern. There's no real strong hot spot, but there is a hot center point in this projector pattern. And from that, we are getting 760 lux with our measurement here. Now let's go to HID and see how it looks. All right, we're gonna flip on our HID, and you can see, again, it's gonna take a couple seconds to get up to full brightness. But you can see we maintain the nice beam pattern. The projector is really going to maintain the overall cutoff no matter what we put in it. So the next thing we have to look at is how intense the whole pattern is. And with an HID installed, you can see really nice pattern as we get up to full brightness here, and we have 800 lux total. So 10–15% brighter than that original halogen bulb. We maintain the whole pattern pretty nicely with this setup. Now let's try out our LEDs. Starting with that CREE style LED with the bigger chip, when we turn this on, you can see, yes, we have a cutoff, but there's no hot spot at all anymore. And when we measure it, we only get 280 lux. So that's half the output from that original halogen. These bulbs are a huge downgrade. So again, for the LED bulbs, it really depends on the quality of the LED bulb. Let's put in a good one, our Diode SL1, and see how it does. So when we have an LED installed on this headlight with good focus, you can see our hotspot returns. And on this one, we have 780 lux, which is a slight upgrade from our halogen performance. Of course, with the LED, we'll get much more lifespan and the modern color as well compared to halogen. This is gonna really vary based on your projector. Good projectors are gonna have really high lux with halogen. So this one is a Honda, they have decent projectors. Subaru's not nearly as good. But in many cases, HID might be a better choice in some projectors as LED continues to catch up. So what you can expect for projector headlights is that LED bulbs will be a slight upgrade from halogen with all the features of LED. HID, it's a complex system, but it might give you better performance in projectors. As we said, for reflectors, LED is the absolute best choice because of the better focus. So as you can see, there's a lot of factors to consider when choosing LED or HID, especially depending on which type of headlamp you have and the quality of the design of your headlamp, or just the convenience and lifespan that you're looking for your solution. You can find more information at diodynamics.com or feel free to contact us. Thanks for watching.